section 3 in this unit again, because it ties so nicely into all of our other stuff. We're going to do some graphing of inequalities. So it's a little bit different than what we had done before, where we actually had the entire parabolas above or below their x-axis. We're going to be dealing with kind of shading entire regions. Now, the only reason I put this little clause in here is just so I don't have to change the phrasing in case there's a year that I actually teach Foundations 20 before, or if students have already taken Foundations 20, but that's beside the point. We'll be doing some of this stuff again next year, or sorry, next semester in Foundation 20. I know that at our school, we usually do a pre-calc first semester. First example, we're going to graph each inequality, and yeah. So you'll notice in this question is very different than what we had done in the previous section, because we actually have two variables. The previous one, we only had x. So we actually have are able to graph entire inequalities here. So the first thing we want to do is we want to get into y equals mx plus b form, which means we want to get into the equation of graphing a line. So the first thing we'll do is subtract the x over. So y is less than or equal to negative x subtract 3. Well, since this is actually in the equation of one line, we're not graphing two things, we're not doing anything further. We're just going to graph the line negative x minus 3. So that means that we're going to be starting at negative 3 and be going down 1 over 1. 1, 1. Of course, I'm going the up 1, left 1, so I can graph this as best as I can. We're going to be learning something on the back side about these lines in a second, but we'll deal with that later on. So the first thing we'll be doing is we're asking ourselves, where is y less than these points, or less than this line? So we're asking, basically, where is below? Where would below this line be? And the answer is down here. And that's all we're going to do. It's really nice and slick, really nice and easy. That's all we're going to do. Now we can go on to the next one. 3x minus 2y is greater than 4. So let's get the y by itself. We're going to subtract the 3x. And I'm going to do this in 2 steps to help emphasize a point. Negative 2y is greater than or equal to negative 3x plus 4. And then to get the y by itself, we're going to divide by negative 2. So dividing them all by negative 2, we'd have the y there. We'd have a 3 over 2x and a negative 2. But, kind of mentioned it in one of our earlier units, that division by that negative will change that sign. Instead of being greater than or equal to, it's going to switch to a less than or equal to. Dividing by that negative switches our inequality. Alrighty, now we can graph it. Y-intercept of negative 2, slope of 3 over 2. So that'll be up 3, right 2. Or down 3, left 2. If you can actually see me, I'm actually leaning into my screen to make sure that I can actually get the dots right, because apparently I can't see without seeing the nice big smartboard. But we will graph this as nicely as we can. The good news is it's the same sign as the first one. The bad news is we have to have an understanding of where would less than be. Well, it's not always going to be to the left of a graph. It's going to be to to the end. It's going to be below it. And if our line is here, less than, it's actually talking about here. So this entire part down here is less than that line. What I will usually do for either of these is I will actually have I'll actually hold my arm with my forearm, so usually my left. And this one, I'm asking if I have my left forearm and I'm in front of me, and I have my arm right in front of me. So I'm actually standing in front of the screen here. I'll ask myself, okay, where would below my arm be? Well, be down here. If I hold my arm like this in front of me, so just in front of my chest, just at an angle, below it would be that way. And last question. Well, first thing we'll do is move that 2x over. So we're going to have a negative 3y being less than or equal to negative 2x, subtract 6, divide by the negative 3. But dividing by that negative 3 means we're going to divide everything by that negative 3. Negative 2, negative 3 would be a positive 2/3 x. So negative 6 divided by negative 3 is a positive 2. And because we had divided by that negative, our less than or equal to sign now is going to become a greater than or equal to sign. So now we can graph. Y-intercept of 2, which is that b value, slope of 2 over 3 means up to right 3. Or down to left 3. I'm just going to notice that my line is just off, but that's where the wonders of technology come in. I can adjust my line. Okay, so now I have to ask myself, where is our graph greater than this line? Well, greater than in this one, I'm just going to duplicate this. Greater than that line. So I'm holding my hand literally in front of myself. Actually, I'm going to just rotate it. Make it look a little bit closer to the line. Sometimes when I'm doing it, I absolutely feel like I'm doing the wave. If you don't get that, here, I'll show you. Group. You know, like I can just, ooh. I feel like a breakdancer. Sorry, I digress. Greater than, well, we're talking about above the line. And really, when we're doing these questions, all I care is just you've shaded in some kind of general region like that. We're going to do some more specific stuff in Foundations 20, but for Pre-Calc 20, this is all that I'm going to go into. All right. Second example. Are the ordered pairs 0, 0, -2, -3 over 2, and 0, -4 solutions to the inequality? Well, to do that, all we're going to do is plug our stuff in. We're going to plug our x and y, xy, xy, and xy into our equation. So let's do it in reds. Oh no, we'd have 0, we'll use black, subtract 4, times 0 less than 4. So is 0 subtract 4 times 0 less than 4? Well, 4 times 0 is 0. 0 subtract 0 is 0. So yeah, that one's true. If we do the exact same thing here, negative 2 subtract 4 multiplied by that negative 3 over 2. Is that less than 4? So let's see, negative 4 times by negative 3 over 2 would be a positive 12 over 2, which is positive 6. Negative 2 plus 6 is 4. Is 4 less than 4? Hopefully you say no. 4 is not less than 4, it's less than and or equal to, but definitely not less than. And finally, our x is 0. Subtract 4 times by our negative 4. So 0 subtracting 4 times negative 4 actually comes out as 16. Is 16 less than 4? No. So only 0, 0 would be a solution to here. And what that means is if we were to graph this, the point 0, 0 will be the only one in the specific region. For example, if I tie it back into this one, a specific answer will be like this. So negative 4, negative 3 is a solution to this line, or sorry, to this inequality, because it's in our shaded region. 0, 0 would be in the shaded region of this. These two would not. But let's just a quick calculation. We could have technically graphed it and found out. That would be another way of doing it. Alrighty. So some of you had seen this before and wondered what the heck. Well, it's because I've tried to actually do the same kind of sketching. I think I just used my trackpad to do this, but it still works out. All we're going to do is we're going to write down what the inequality is. So meaning we have to identify what is the actual equation. So our equation here, let's see, our y-intercept is 3. Let's see, I can see that's, I think I tried my best. Yeah, I was trying my best to make it go through these points. No, I guess I didn't. Well, let's use what we have. Let's see, another point that it actually goes perfectly through, I'd say it probably would be this one. So what would be our slope here? Let's see, it would have to go down 3, 8. So that would be going down 11. And it would be going over 1, 2, 3, 4, 5. So negative 11 over 5x. Y-intercept is 3. So the equation of the line would be y equals this. Now, because we shaded this region, we'd have to say it is greater than or equal to. And we'll be talking about that equal to literally in the next example. But this would be the equation of the line, and that's how we would graph it. I know that questions that I'm actually going to give you, like that are not me trying to do my best with Microsoft Word, are going to have a lot better equation than this, but that's beside the point. Alrighty. This one looks pretty much the same, but at the same time it is slightly different. It's still a line. Our y-intercept is -1, and it looks like, yeah, I was actually able to make this line look somewhat actually nice. Looks like our slope will be a rising 3, running 1. So 3 over 1x, and our y-intercept will be -1. So it'd still be y. Now, this side of it would actually be less than that line. And this is actually all that we're going to be doing. Because you'll notice the difference between these two equations, or these two lines. This one is a solid line. A solid line is going to be using the greater than and or equal to, or the less than and or equal to symbols. A dashed line, like this one, some textbooks will use the phrase stippled, dash, stippled, all that kind of jazz, is going to use the greater than or the less than sign. Yes. Sorry. So if you see a dash line, it's actually just going to be using the less than, or the greater than signs. Just no equal to. Okay. Just about done. We're just going to talk about the context. Actually, for this year, don't even worry about it. We're not even going to worry about these. Well, we'll be doing this kind of stuff in Foundations 20, but it's really not hard. We're just going to be doing an equation of it and see some stuff. So I'll make sure I adjust your questions accordingly. I just want to get into our parabolas, and so we can actually graph things like, or so you guys have some time to work. So when we're graphing quadratic inequalities, it's not really any different. The biggest difference, though, is we're going to be graphing a parabola. So our y-intercept here, opposite on the inside, sorry, no, y-intercept, yeah, I definitely said that. Vertex, opposite on the inside, same on the outside, so 4, -2. It'd be a 1 in front, which means we're going to be going over 1, up 1, over 1, up 3, up 5, that'd be 7. Before you get into sketching it, notice the sign. Sign is greater than, which means we're not going to do a full solid line here. We're going to do a dashed line. Now the question is, greater than this parabola? Well, to be greater than this parabola, we'd be talking about this part. This entire part in here, including that stuff that does go below the x-axis, is all greater than the parabola. So if we kind of tie it back to our lines, greater than is above that line, less than is below the lines. For parabolas, exact same kind of idea. Oh, of course I do this. Fantastic. Just make sure you change that sign to less than and or equal to. Of course I missed one question in there. Jeez. Okay, anyways. Vertex, opposite on the inside, same on the outside. So 3, 1. The 2 in front means instead of going over 1 up 1, 3, 5, 7, 1 up 2. And 6. Then it would be 10, 14, so on and so forth. It is going to be a solid line here. I'm just going to do that part. Try and sketch this as best as I can. And then we're going to shade less than this parabola. Well, less than the parabola means everything below it. And this entire part here is below that parabola. A little bit mind-boggling, but fun. Okay. All So we have here, and then we'll get back into a word problem with that. Yes, we are going to do that word problem just because it does do some nice skills. Okay, so y is less than or equal to negative x squared minus 2x minus 4. Again, just like we had talked about the last section, we could absolutely be using our vertex formula. But because it's a formula and it's really nice to do, let's do some completing the square. So I'm going to write down that equation. So we're going to do it nicely. Okay, first step, factor the a value from the x squared and the x term. So we're going to factor a negative 1 out. Factor from here, factor from here. That 4 on the outside. Find half of that negative 2, which is negative 1. And we square it. We're going to add and subtract that number inside that grouping right here. Next step, factor the first 3 terms as a perfect trinomial square, which means you're looking at that number. Try and color code as best as I can. This would turn into an x subtract 1 squared. Subtracting that 1. Then we have to distribute our a inside, and then we'll have to combine our like terms. So we would be distributing that negative 1 in front of this x subtract 1 squared. Negative 1 by negative 1 is positive 1. Plus 4. So our full final complete equation will be negative 1 x subtract 1 squared plus 5. And that little front matter, that y is less than and or equal to this, is just all that. So when we graph it, opposite on the inside, same on the outside, so 1, 5 over 1, that negative 1, we're going to be going down. Hey, 4. Look at that. That's our y-intercept. Don't you just love it when things work out? Then be 3, and our 5. 7 would be off. Now it's a less than and or equal to, which means solid line. Now this one, where is less than? Well, less than this parabola. Everything on the inside here. And there should be. Reason I have this word problem is because we're going to have to do that stuff before or do it again. So we're going to have some fun. So it says a satellite dish is 60 centimeters in diameter and 20 centimeters deep. Dish has a parabolic cross section. We're going to locate the vertex of the origin, sketch a parabola that represents the dish, and then determine the inequality that shows the region for which the dish can receive a signal. So first off, I'm going to sketch a Cartesian plane. Now it says the satellite dish is 60 centimeters in diameter. We're going to locate the vertex at the origin. So centimeters, 60 centimeters in diameter means everything out here, this entire region here, from there to there, will be 60 centimeters, which means there would be 30. That would be negative 30. also says that it's 20 centimeters deep. So there would be 20, which means we have a point 30, 20. So far, so good. Well, I hope so. I think so. So if we want to determine what the equation of this would be, we're going to put it into vertex graphing form. Squared plus k. So the first thing we do is we know what our vertex is. This h comma k, actually I'll put this in green. H comma k is 0, 0. So we can plug that into here right away. 0 and 0. Subtract a value. In order to find out what our a value is, we're going to have to use one of our points on here. Well, the great thing is with all this information, we have that. We have an x and we have a y. 20, 30 equals that. And then we can keep on going and solving. So 20 would equal a multiplied by 30 subtract 0 squared, while 30 subtract 0 is 0 or 30. 30 squared would be 900. Plus 0, nothing. To get the a by itself, divide by 900. And by reducing our fraction, a what goes into 20 and in 900? Well, that's actually the number 20. So 20 goes into 20 once, 20 goes into 90, should be about 45 times. Where's my calculator? 900 divided by 20. Alrighty, 45. So the a value would be 1 over 45. So the equation would be 1 over 45 x squared. And we have y. If we want to determine the inequality that shows where we're going to receive the symbol, well, we're going to be receiving a signal for everything that would be greater than this parabola. Technically, it would just be, I would consider it just be greater than, because we really can't receive a signal right on here. So greater than would work for me. The reason we don't have that add 0 or subtract 0 on the 0, because doing those zeros just is going to be redundant. Alrighty. Here's some questions. And hopefully you guys have a little bit of fun. There's our equation. And there you go.